Alright, hello and welcome back to my tools tutorial in Unity. Today we've been covering programmable tiles. So basically what that means is I've added code that would allow like different features to be added and like for tiles to do things when they're placed. So say if you had a selection of different grass tiles, to break them up, but you didn't want to place each one of them individually, you'd be able to add a script to the one grass object that would, or grass tile, that would, when placed, select from one of those grass tiles and then use that as a sprite instead of just using the one that was set initially. Just like for convenience, basically. So I'll just show you here. So as you can see, we've got all list, just like all the prefab tiles that we've got. So first off, I'm going to have a random tile rule. So you can see here we can just add, say, add sprite to list, add that one, and add that one. Alright, add random tile rule to tile. Alright, so now we've got a rule on the tile. So if we go to the painting mode, actually we need to select it first, sorry. Painting mode, and we select paint sprites, and if we paint this sprite, it will choose one of the random sprites to paint. It should do. It might not be choosing the last one because of an index error, but whatever. But you get the principle of it. So now if we expand this grid, so let's choose this one. So actually, no, let's add a neighbor change rule this time. So let's say if the initial tile we had, so that grayish tile, is next to the yellow tile, or the yellow color palette swap, then we change to this purple tile. And if it's so to the left, to the right, down or up. So if this yellow tile now is adjacent to any of the, in any direction is adjacent to the same pattern but greyish, then it will change into that purple tile. So let's just swap the tile, and you can see there, it's changed there, but if we place it here, it's still the yellow one. Purple, yellow, purple, purple, yellow, purple, and you get the idea. Finally, the last one we have is we can add an animation. So we can just cycle through sprites. So we add that one, add sprite to animation, add that, add tile to animation, and we'll add that one, why not? Add animation to tile, so that has an animation and it doesn't really display the float properly, but whatever. So now if we paint some of those blue tiles, so just click there, and let's look at the camera view for a second, just to make sure that I'm placing them into where we can see when we click play. So down here we'll just have a row of them. If we click play, these should animate. Yep, you see, it's cycling through these tiles. Yeah, which is quite headachy to look at, but whatever, it works. So yeah, let's get on to how this was implemented. Okay, so first up is the sort of base programmable tile class, which the three features I just showed you is based off of. We are using, well, basically just virtual methods, which I've covered before in other tutorials, but in case you haven't seen them, it's basically like saying, all right, we're defining a method, and that might do some kind of task. So here we're returning a string that has info on the tile, which is just used for the GUI or what we want to do when we place the tile. But if a class inherits from this programmable tiles class, then it can overwrite this method and have its own functionality. And even if we like search for programmable tiles, so if we use like the game object dot get components programmable tiles. So if we use something like that, that would return an array of programmable tiles or classes that inherit from programmable tiles. Sorry. like neighbor change or random tile. And since they have implementations of this method, if we call onPlace tile for each of these child classes, then it would like call that individual class's functionality without having to specify that we're actually accessing that class, which is accessing the superclass or parent class or whatever. So yeah, that's how that works. And we do this for 3 different classes, so as you can see. First one is the neighbor change rule of the neighbor change, which inherits from programmable tiles here, and has the override for onPlace tile. Well, first it has a list of neighbor chain rules called my rules, which are basically the rules that the tile has to adhere to. On when the tile is placed, this method is called. Basically, what it does is it gets the adjacent tiles to it. So it has a size area for. If it's like, well, basically, I explained it uses the same code as last time. The brushes when we wanted to get a square area, but we're using a fixed size because we only want the immediately adjacent tiles. So we use a 4, well, size of 4, and that gives us all the tiles adjacent to whatever tile we've selected. And so once we've got all that by using this, the methods we've already written, so you can check out whether it should be explained last episode in the brushes one, because essentially the same. What we do is we get the adjacent tiles by using the get tiles as chunks, get tiles in area with the top right corner and bottom left corner of this area we want to use. Sorry, I'm not doing this very well. I feel a bit ill recently, but whatever. Yeah. So we go through each of these tiles, and if the tile is within 1.5 units, just to make sure that it is immediately adjacent and isn't like far enough away, just to make sure there are no errors or whatever, we call this method called test for rule match, which basically just tests the neighboring tile against all the rules we have. So it'll check like what sprite it's got and the direction it is relative to the tile that this script is on, to make sure that if there is a rule match, then this tile is changed accordingly. So what we do is we get the sprite off the neighboring tile, which is passed in here. We also get the direction by calling this get direction from neighbor, which is basically just it uses the X and Y position to work out what direction it's from. So say if the X position of the neighbor is more than the X position of this game object, then we know it's to the right of it. But if the Y coordinate, since we're in a grid and they're all placed equally, if the Y coordinates aren't identical, then we're going to assume, all right, this is diagonally sort of up or down. So it's so it's in a diagonal sort of direction. So we don't want to use that tile. But if the Y coordinates are the same, we return myDir.right, and myDir is just an enum which has up, down, left, right, and invalid. Just so because we didn't really need to use vectors. We just need to say what the direction is and whether it matches. Sorry, let's train coming past. And likewise, we have one for the left. So if X is the neighbour's X coordinate is less than this object's this tile's X coordinate, and again make the Y check. Sorry. And again, if the X coordinate is the same, we're assuming, all right, it's either above or below. So if neighbor.transform.position.y is more than the Y, then we return up, otherwise we return down. And that's that. And then, so if the direction between two tiles is not invalid, or doesn't return invalid from here, then we go through all of the rules and we check this game object against the neighbor, and we pass in the direction as well to make sure. And I'll cover that in a second because that's the next class we'll get onto. But again, we have this other method called addRule, which basically takes a sprite, which is first sprite is what this tile should be. The second one is what the neighbor should be, The first one is what we should change to if the tile, if the first two sprites match up with the rule, and finally day is just the direction that it needs to be in. And finally, again, you might have seen the get info on tile virtual string, which got an override here, which says return neighbor tile change with X number of rules based on how many rules you've added to it. That's just for the inspector because it makes it look neat and easy to read and stuff. So yeah. Okay, so this neighbor change rule class is basically just a way of storing the rules for neighbor changing. So we don't actually need the neighbor change this bit, so I can get rid of that. So I'll just comment that out for the time being, just in case. I know you can do multi-line comments, but whatever. All right, so we've got our first. Oh, we've got sorry, getting ahead of myself. Three sprites: my tile, the neighbor tile, and the change to, which correlate to the arguments passed in here for when we're creating a new neighbor change rule. We've got the my day direction to tile. We've got a method to initialize these variables when the class is added. I kept it as a mono behavior because it's just easier to serialize and I don't have to worry about that, about saving it between plays and stuff. I mean, it doesn't really need to be, but by having it as it sort of saves me some hassle. And we have check rule. So we pass in this the tile to check, the neighbor, and the direction. We get two sprites, and if the sprites match up with what the rule's been defined to have, and if the direction also matches up, then we change the sprite renderer, and that's that. That's how that works. Thankfully, the random tile is much simpler. So basically, we have a list of possible sprites it could be. We get a random number that's in that random index for that list, and we set the sprite renderer of the tile to be that sprite, and that's called onPlace, and we have an initialize method, and we just call it with that list. And finally, we've also got an override string, which again just returns tile randomizer with however many sprites that you've added to the list. Let's probably zoom in, view, zoom in, view, zoom in. And again, animation works a little differently. We have a list of sprites, a value to reset the timer to, so that'll basically be each frame will last for this timer reset value. We've got a timer which just counts down and a counter to show what sprite we're currently on. And on update, it will just basically, this code here will basically just count down the timer. Once the timer is less than 0, it'll change the sprite renderer to be whatever the counter index refers to in the my sprites list. It will then either, if the counter is less, it has not reached the end of the array or list, sorry, then it will increment. Otherwise, it'll just reset to 0 and bring it back to the start of the list, and then the timer value will be reset to the timer reset value, and that's that. And then we've got initialize for passing in a list of sprites and a timer or float for the timer reset value. And yeah, and we don't actually need to do anything on the onPlace tile, so we don't have that doing anything basically. And as for the get info, it just returns tile information with X frames at Y seconds per frame. So yeah, and these as for calling these override methods, so onPlace tile, that is done in the tile chunk on the set tile. So it's changed from last time we saw it. We've added this new array called Programmable tiles. And on each case statement, so for each row of the tile chunk, we call, all right, if tiles is now, we just get components on the game tile, sort of type programmable tiles. Sorry. What that does is returns an array of any programmable tiles or classes that inherit from it that are on the tile that we just placed. So if tiles is null, you don't do anything. Otherwise, so if it has found something, then for each of the tiles we call tl.onPlaceTile, and that will, either do the randomizing or make sure that the neighbor rules match up or whatever, and that is done in each place here. So I'll go for 1, 2, 3, and 4. So yeah, that was all that. Now onto the interface. All right, so we're now going to go on to the little inspector bit of this programmable tiles bit. So first off, we got an array of strings, which will just act as like a little options menu. So we're going to have a view tiles option, because we're going to implement this as part of the sprite selection method, tab, sorry. So this first bit will just be like viewing all the available tiles and selecting them for painting, like we did previously, basically all the original functionality of a sprite selection. But the add rules is a new one, so that'll be where we actually add all the rules to tiles and whatnot. And this int just basically controls which one is selected and displays the correct inspector accordingly. All right, first off, we got 2 vector 2s, because you need vector 2s to draw scroll bars and whatnot. They are intentionally left uninitialized, because the actual beginning scroll area will handle all that for us, so there's no need to worry about that. We've got the game object of the prefab we're processing, so we have as you saw in the inspector, we have we have like a list of a little scroll area of sprites or prefabs that we could place in the world. So if we select one of these, that becomes the prefab to change. Prefab to process, sorry. We've got 3 booleans: animate, adjacent, and random. These, of course, correlate to the rule we want to add. So that is defined by buttons. So we press a button, we get either animate, adjacent, or random, and that will draw the options and GUI that we need to add these rules without dragging and dropping and stuff. So yeah, I'll show you that in a minute. Sprite. So again, we've got some sprites to control what we need basically. So we've got the adjacent sprite for the adjacency, the neighbor rules, and sprite we want to change to. We've got 2 lists. One is the sprites that will be part of the animation. One will be the sprites that can be randomly selected from. We've got an array of programmable tiles, which will be static, actually. Static. These are basically the tiles that these are the existing programmable tiles on the current prefab, so you might be able to have more than one, but I wouldn't recommend it unless you're expanding the system yourself. We've got a myday, which is just used for when we're adding the neighbor change rules, just to store it before we actually add the thing in case you want to change your mind. We've got a static display sprite. What is that used for? I think that's just used for drawing the sprite somewhere, I'm not sure. And finally, we've got the animation timer, which is just default to 0.1 seconds. Sorry. Now, if we go scroll down, that's option 3. It should be option 5, I believe. Oh no. Okay. No, this is selecting sprite because it starts at 0. My mistake. So yeah. So first off, the main change is that instead of just going straight to the GUI for sprite selection, we have this toolbar. And as you say, it was similarly to how we do it for the 5 main options. This small toolbar has the tile process options, so that is then stored as an integer in the select process options, and we also draw a label for what option was selected. So basically, if we have the initial one, which will be 0, because it's the first element in the array of options, as seen there. So it'll have view tiles and add rules. Let's see, let's get back to that. So yeah, so if it's 0, we have what was the original code in this section, where it will just draw a list of, or it'll draw all the prefabs you can find in that the folder we store them in, and it'll draw buttons for them, so you can select them and paint them as you wish. But if it's the select process option is 1, so we want to be, that'll mean we are adding rules. So so that'd be 1, 0, and back to 1. Sorry, like whenever every time it recompiles, it gets rid of all the values. So that's why it sometimes does that. Yes, and yeah. So first off, we start a scroll area with the process scroll position. Basically, what we're doing is this is the little scroll area that we store our buttons in for selecting a tile or prefab to process. And what we do is we begin this scroll area. We're setting, all right, we want to have a fixed height of 170 pixels. So it's basically just displaying one of the icons. But we could like give it a fixed width by using GUI layout.width, but I'm not at this point. We're just using it whatever the width of the actual inspector window is. We have to both pass in the process scroll position and set it with that value. So it's sort of like the sliders where you need to have the value to be displayed in the scroll position, as well as setting the scroll position so any changes are updated. It's odd, but it works. And then we are trying, so basically we have a try-catch statement, which stops somewhere. Where does that stop? Oh well, I think that covers actually the entire of it, because it was crashing if the thing recompiled, so I'll have to go over that in a bit, but whatever. Yeah, so basically we check if we don't actually have any tiles loaded. We just basically have a load sprites button, which is copy and pasted from here. Basically just loads the sprites into a list if there are any at all. And otherwise, so if there are tiles in the list or prefabs that we found, we begin a horizontal area for each of the tiles that we found or prefabs. We get the asset preview. We draw a button that sets the prefab to process to be that tile if the button is pressed, and then we get the programmable tiles from that prefab if any exist. And we do that for all of the tiles. Then we end the horizontal view, so we go back to place some things below whatever the last item placed in the inspector was, and then we end the scroll view because we just want to have that for scroll. So, and then next up, we have a check. Basically, if the prefab process is null, it'll just say we've not got tile selected. Otherwise, we begin a horizontal area. So this means that, if any elements drawn will be placed horizontally rather than vertically. So I'll be like, so it'll draw the asset preview of the prefab process, and then it'll begin a vertical area and draw 3 buttons, basically saying for each of the different programmable tiles we can add, and then it'll set these buttons so either adjacent, random, or animate are true. And then we have just an end vertical and horizontal, and that bit is what draws this bit here. So we have so it starts the horizontal. So we have just the preview of whatever tile you've got selected. Then it begins a vertical, which places the 3 buttons above each other in a row. Then we end it, and it starts end both the vertical and horizontal. And then that will let us start placing things below the little preview icon again. Okay, so now we have, based on these 3 booleans that we have here, we can display some different stuff. So first off, for adjacent, if that is true, we're wanting to create a tile with adjacency rules, so it'll change based on what sprites are next to it. So first off, we have a label, and this adjacent sprite. So basically what this does is it will, let's just show you. So a neighbor change rule. Basically what editor GUI layout.object field is, we just pass in this image sprite that we want to throw it in a type of. I don't know why you can't do sprite, but apparently you have to do type of and then sprite, so that works. And I'm not sure what is that boolean for. Allow scene objects. So we're only wanting to search through our sprites that are in the in the project folder rather than ones that are in the scene. So this is what we do. So we don't. This base build basically says we don't want to search objects in the scene. We just want to search the assets that we have. And what this does is basically allows us to do this to assign the adjacent sprite. So we can, like, this is basically showing us all the sprites I've got in my assets folder for this project. So we could just select any one of them, and and similarly we have one for the sprite to change to basically the same thing for a sprite to change to. So we can click there and click on that, and we can select it. Easy peasy. Yeah, that's all just stored in a begin horizontal and end horizontal label to say what it is assigning. And finally, for this, we've got the begin horizontal, and we just draw 4 buttons for up, down, left, and right to assign the day for my day.up, down, left, and right, whatever. And it'll display a label with whatever the day selected is. And we end horizontal just so that draws the four whatchamacallit buttons. That's the one. And finally, we have a button just to like add the rule once you've assigned all the things. It has a couple of checks to make sure that everything has gone correctly. So it'll check if the sprite's changed to is null, or the adjacent sprite is null, or the direction is null. Then it will use the editor utility .display dialog that we covered in an earlier episode to say you've got to select all the things. Like you got to select the neighbor, the sprite to change to, and a direction for the neighbor change rules. And yeah, so it won't let you add the rule if one of these conditions aren't met. Otherwise, it will add the neighbor change to the tile, or if there isn't one. But it will get it. It'll get the existing one if it's there. Just so you aren't adding like multiple neighbor changes. We only need the one. We have multiple rules. Then we call the add rule, and we pass in the appropriate sprites. So it gets the sprite of the prefab here, then the sprite that should be on the theoretical neighbor, and the sprite we want to change to, and the direction that has to be met. And then we update the list of programmable tiles on the current prefab we're editing to reflect the new one we've added. And finally, we just refresh the asset database to make sure all that updates and whatnot. Okay, and that is what it gives us there. I'll just switch over to the animation. All right, so again, for the adding the animation tile, or script or whatever, it's a similar process. So we've got sprites to form the animation, just a label, and then we check if there aren't any animation sprites in the list that we had, or if there aren't any added, then we don't draw anything. Otherwise, we will just basically draw the list and what the index of the sprite is in a list, in a little scroll view. So we do that, and then we have a label and the asset preview of the sprite. And we have a button just in case you added one by accident and you wanted to remove it, and that will basically remove the sprite or the sprite from the animation in the list. But just to prevent an error, we have to return after we remove that, because Unity doesn't like cycling through lists when you're editing them at the same time. So if we continue going through the list, it would say, oh, the list has been changed, throw an error or something. So basically just returning means we stop doing it for this cycle, and then we'll redraw it next time we come around, and everything will be fine. And then we end the horizontal here, and finally we end the scroll view, and that's that. And that ends up looking something like this. So if I just add sprite, I think I have to add 4 to whatever it is. It's 5 for the scroll view to appear. Yeah, so we have a little scroll view, and then again, we can remove sprites as and when we want to. Okay, now we've got a little thing to set the reset time. We've got a little text box to set the time per frame. So I've got a text field, and that will just take the animation timer.toString, which is just a float. We have to use float.parse to try and get a float value out of the text field. Yeah, and that's about it for it. And again, we are using this editor GUI layout.object field to assign display sprite, and display sprite is basically just what sprite you've chosen that you might want to add to the list of tiles to animate through. We'll try and come and touch. And again, we just got the same parameters passed in, so we've got just a string to like as a label or whatever. The sprite we're assigning to, the type, so we've got sprite here, but you can have like texture 2D and whatnot, and whether we want to search through the scene for assets, in which case we don't. And again, we have a button to say that we want to add the programmable tile to the prefab. First off, we do checks to make sure that. This is adding the sprite to the animation. So if the sprite is null, it will bring up a dialog saying that you need to add a sprite to the animation, or select a sprite and to add it. And then if it'll check that the list is initialized first, and then it will add the sprite to the animation list and set the display sprite to null. And finally, we've got the actually add the actual button to add the animation to a tile rather than adding a tile to the animation. And again, we check if the list of sprites is null or empty. We say you need to have at least one sprite in the animation. It should probably be two actually, but it doesn't matter. So if the animation timer is less than or equal to 0, we're saying, all right, the timer reset must be above 0. And if both of those conditions are met, we just add the tile animation to the game object and we initialize it and we reset the list of sprites and we refresh the list of programmable tiles on the prefab. And finally, for random, again, it's pretty much the same. First, we have a check to make sure the list is not null or empty. Then we draw a scroll position for all the sprites in basically an identical way to the animation. So we have like a label saying what the sprite's index, a texture, we get the asset preview and draw that, and then we have a button to remove the sprite from the list, and then we end with this horizontal view, and we end the scroll view after that, after we've gone through all of the possible sprites in the list. Right. Then we begin horizontal. Again, we have a GUI label for sprite to add, and we use this object field for a convenient way to assign the sprite. And again, we're adding sprite to the list, and if display sprite is null, then we say you need to have a sprite selected or whatever, and then otherwise it will check if the sprite is null. Then it will initialize the list. If the list is null, it will initialize it, sorry. Then it will add the display sprite to the list and set the display sprite to null. So pretty much the same as adding the animation to the list. And finally, we've got the add rule to tile, whereas it will check if either the list is null or of length 0. It says error, you need at least one sprite. And then if it's all good, then it will add the random tile script to that prefab and call the initialize method, and with the list of random sprites it will reset the list of random sprites here, and then it will refresh the list of programmable tiles on that particular prefab. And finally, we've got a little bit here for if you want to remove a programmable tile from one of the prefabs. So if the list of tiles on current prefab is null or length 0, then it doesn't matter. Otherwise, we say, just draw a label saying these are the programmable tiles on the selected prefab, and we go through each of them, and we begin a horizontal layer. We begin a horizontal, so we're drawing adjacent to each other. we draw a label saying what we want to draw, or we use the get info, which again just returns some information about the tile. So in this case, we return whatever tile randomizer with however many sprite possibilities it has. Level is there, and then if we click the button remove programmable tile, it will destroy immediate that particular instance of a script. And this second boolean is basically saying that we want to be able to destroy assets or something. So we're saying, yeah, we want to edit the original like prefab. So yeah, that's basically what we have to do. And destroy immediate means it gets destroyed straight away, and that's what we have to use that instead of just normal destroy for. What was it? For like if we're editing assets rather than just in-game game objects. Finally, we reset the list by getting the components programmable tiles, and we return because we've edited the list and we don't need to draw it anymore because that'll produce an error. So yeah, that's pretty much it. I don't think there was anything else new. So yeah, that was our programmable tiles. I'll just give you a quick demo again. So for one, we got random tiles. Actually, I need to select that here, don't I? So first off, we got random tiles. So this will perform one of 3 or 4 random tiles. Just in case you say I had like multiple variants of a grass tile or a water tile or something, and you wanted to add them, that would work out. That'd just be an easier way than selecting from 12 individual, or for however many individual tiles you would have. Second off is the adjacency one. So this yellow sprite, or yellow one, will change to a purple one if it's adjacent to one of these greyish tiles. So if I click there, you'll see it change to a purple. But if it's next to another yellow, it's still yellow. And you'll see that. And that happens with any direction, but you could limit it to just one direction, maybe more than one, who knows. It's whatever you want. And finally, if we select the blue tile, it's actually an animated tile. Well, as you can see here, I'll just add a few more, just to prove. And if we click play, you'll see that it's cycling through a number of different tiles. So yeah. So cheers for watching. Like, comment, subscribe, all that shit. Go check out the links in the description. Still working on Loud or Quiet. That's going well. Apocalypse mode is pretty much done. Just got to do some cleanup and bug fixes, and that should be pushed to itch.io and hopefully having a Steam release later in the year. There won't be a video next week because I'm on holiday and I don't get back till like midnight on Tuesday, so there won't be time. So yeah, I might make a quick video on Wednesday about Apocalypse mode whenever I wake up. So you can look forward to that. Well, other than that, yeah. Cheers for watching. Bye.